high voltage 15 kV switchgear and cables can generate strong magnetic fields. These fields can interfere with sensitive electronic equipment. Examples of such equipment are computers, point-of-sale systems, and security cameras. The rectifier, located above the retail space, can also emit electromagnetic radiation. This radiation can disrupt wireless communications. Furthermore, it can interfere with electronic devices. Electrical equipment can generate a significant amount of heat. This heat can raise the temperature in the retail space. It can make it uncomfortable for customers and employees. Heat can also damage sensitive materials and equipment. The operation of the electrical equipment can produce noise. This noise can be distracting and disruptive for customers and employees. A malfunction in the electrical equipment could result in a power outage in the retail space. This would disrupt operations and cause inconvenience to customers. The rectifier above the retail space is a critical component for the local transit authority. Any disruption to its operation could have significant consequences. Improperly shielded or grounded electrical equipment can pose an electrical hazard to people in the retail space. Workers installing or maintaining the electrical equipment may need to enter the retail space. This could increase the risk of accidents. Magnetic field measurements are a valuable tool to assess the potential impact of the electrical equipment in the retail space. These measurements should be taken in all areas of the space. These areas should be where sensitive equipment or people will be present. The results of the measurement should be compared to establish safety limits. This will determine if any mitigation measures are necessary. To mitigate the potential problems outlined above, the following measures could be considered. Firstly, shielding the retail space from electromagnetic interference. Secondly, installing proper ventilation and cooling systems to reduce heat buildup. Thirdly, providing noise-reducing barriers. Fourthly, installing backup power systems to prevent outages. And fifthly, ensuring proper electrical safety measures are in place. The electromagnetic interference, also known as EMI, is a disturbance generated by an external source. This disturbance affects an electrical circuit by electromagnetic induction, electrostatic coupling, or conduction. The disturbance may degrade performance or even stop the circuit from functioning. EMI can be caused by a variety of sources, both natural and man-made. Natural sources include lightning and solar flares. Man-made sources include radio transmitters, cell phones, and electrical equipment. The effects of EMI can range from minor annoyances to serious problems. For example, EMI can cause static on a radio, interfere with the operation of a computer, or even damage electronic equipment. There are a number of steps that can be taken to mitigate the effects of EMI. These include shielding electronic equipment, using filters to block unwanted signals, and grounding equipment properly. Shielding involves enclosing electronic equipment in a conductive material, such as metal, to block electromagnetic radiation. Filters are used to block unwanted signals from entering electronic equipment. Grounding equipment properly helps to reduce the amount of noise that is present in the system. Heat radiation is the transfer of thermal energy in the form of electromagnetic waves. All objects with a temperature above absolute zero emit thermal radiation. The amount of radiation emitted depends on the temperature of the object and its emissivity. Emissivity is a measure of how effectively an object radiates energy. Heat radiation can be used for a variety of purposes, such as heating buildings, cooking food, and generating electricity. It can also be a nuisance, such as when it causes electronic equipment to overheat. There are a number of ways to reduce heat radiation. These include using insulation to block the flow of heat, using reflective surfaces to redirect heat, and using cooling systems to remove heat. Insulation is a material that resists the flow of heat. Reflective surfaces are materials that reflect electromagnetic radiation. Cooling systems are used to remove heat from an object or space. Noise is unwanted sound. It can be caused by a variety of sources, both natural and man-made. Natural sources include wind, rain, and thunder. Man-made sources include traffic, construction, and industrial equipment. The effects of noise can range from minor annoyances to serious problems. For example, noise can cause stress, interfere with sleep, and even damage hearing. There are a number of steps that can be taken to mitigate the effects of noise. These include using noise barriers to block sound, using sound-absorbing materials to reduce noise levels, and wearing hearing protection. Noise barriers are physical structures that block the passage of sound. Sound-absorbing materials are materials that absorb sound energy, reducing the amount of noise that is reflected. Hearing protection is used to protect the ears from loud noises. Power outages are a complete loss of electrical power to an area. They can be caused by a variety of factors, including severe weather, equipment failure, and human error. The effects of power outages can range from minor inconveniences to serious problems. For example, power outages can disrupt businesses, cause traffic accidents, and even lead to death. There are a number of steps that can be taken to prepare for power outages. These include having a backup power supply, such as a generator, having a supply of non-perishable food and water, and knowing how to operate essential equipment manually. Electrical safety is the practice of protecting people and property from electrical hazards. Electrical hazards include electric shock, electrocution, fire, and explosion. There are a number of steps that can be taken to ensure electrical safety. These include using properly insulated equipment, grounding equipment properly, and avoiding contact with energized electrical circuits. Mitigation measures are actions taken to reduce the severity of a problem or risk. In the context of the question, mitigation measures are actions taken to reduce the potential problems associated with locating a retail space near electrical equipment. Shielding is a mitigation measure that can be used to reduce electromagnetic interference. Ventilation is a mitigation measure that can be used to reduce heat buildup. Noise-reducing barriers are a mitigation measure that can be used to reduce noise levels. Backup power systems are a mitigation measure that can be used to prevent power outages. Proper electrical safety measures are a mitigation measure that can be used to reduce the risk of electrical hazards. In summary, locating a retail space near electrical equipment can pose a number of potential problems. However, these problems can be mitigated by taking appropriate measures. Shielding the retail space from electromagnetic interference can be accomplished through several methods. One method is to use a Faraday cage, which is a conductive enclosure that blocks electromagnetic radiation. Another method is to use shielding materials such as metal sheets or conductive paints to line the walls, floor, and ceiling of the retail space. The choice of shielding method will depend on the specific requirements of the retail space and the level of electromagnetic interference that is present. Installing proper ventilation and cooling systems to reduce heat buildup is important for maintaining a comfortable and safe environment in the retail space. Ventilation systems can be used to remove hot air from the retail space and replace it with cooler air. Cooling systems such as air conditioners can be used to cool the air in the retail space. The size and type of ventilation and cooling systems will depend on the size of the retail space, the amount of heat generated by the electrical equipment, and the climate in which the retail space is located. Providing noise-reducing barriers can help to reduce the amount of noise that is transmitted from the electrical equipment to the retail space. Noise-reducing barriers can be made from a variety of materials, such as concrete, metal, or wood. The effectiveness of a noise-reducing barrier depends on its height, length, and density. Installing backup power systems can help to prevent power outages from disrupting operations in the retail space. Backup power systems can be either generators or uninterruptible power supplies, also known as UPS. Generators provide power to the retail space when the main power supply is interrupted. UPS systems provide power to the retail space for a short period of time, allowing for a smooth transition to backup power or for the orderly shutdown of equipment. Ensuring proper electrical safety measures are in place is essential for protecting people and property from electrical hazards. Electrical safety measures include using properly insulated equipment, grounding equipment properly, and avoiding contact with energized electrical circuits. It is also important to have a qualified electrician inspect the electrical equipment on a regular basis to ensure that it is in good working order. Additionally, magnetic fields can be assessed to help provide even more safety for the retail space. Magnetic fields are created by the flow of electric current. The strength of a magnetic field is measured in units of Tesla or Gauss. Magnetic fields can interfere with electronic devices and can also pose a health hazard to humans. The International Commission on Non-Ionizing Radiation Protection, also known as ICNIRP, has established safety limits for exposure to magnetic fields. These limits vary depending on the frequency of the magnetic field and the duration of exposure. Magnetic field measurements can be taken using a Gauss meter or a Tesla meter. These meters measure the strength of the magnetic field at a specific location. The measurement should be taken in all areas of the retail space where people will be present. The results of the measurement should be compared to the ICNIRP safety limits to determine if any mitigation measures are necessary. If the magnetic field levels exceed the ICNIRP safety limits, mitigation measures should be taken to reduce the exposure. Mitigation measures can include shielding the electrical equipment, increasing the distance between the electrical equipment and the retail space, or limiting the amount of time that people spend in the areas with high magnetic field levels. By taking these steps, it is possible to create a safe and comfortable environment for customers and employees in the retail space. In the context of electrical systems, several voltage levels are commonly encountered. For example, 480 volts is a common voltage for industrial and commercial applications. 600 volts DC is used in some transit systems. 15 kilovolts is used for high voltage power distribution. Other common voltages include 120 volts and 208 volts, often found in residential and commercial settings. 277 volts is also used in commercial lighting. These voltages are chosen based on factors such as efficiency, safety, and the type of equipment being powered. Each voltage level has specific requirements for wiring, insulation, and safety procedures. Always consult the National Electrical Code, also known as NEC, and local regulations for specific requirements. Wiring and conduit considerations are also important. For example, the use of concrete encased conduit for 15 kilovolt cables and 600 volts DC cables provides physical protection and helps to contain any potential faults. The type and size of conduit must be selected based on the voltage, current, and environmental conditions. The NEC provides detailed requirements for conduit installations. Proper grounding is also essential for electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to trip circuit breakers and prevent electrical shock. The grounding system must be properly designed and installed to ensure that it is effective. The NEC provides detailed requirements for grounding systems. Regular inspections and maintenance are also important for ensuring the safety and reliability of electrical equipment. Inspections should be performed by qualified personnel to identify any potential problems. Maintenance should be performed on a regular basis to keep the equipment in good working order. In addition, it's worth knowing a little more about the rectifier. A rectifier is an electrical device that converts alternating current, known as AC, to direct current, known as DC. Rectifiers are used in a wide variety of applications, including power supplies, battery chargers, and motor drives. The rectifier described here converts 484 volts AC to 625 volts DC. This type of rectifier is commonly used in transit systems to provide power for the trains. Rectifiers can be either single-phase or three-phase. Single-phase rectifiers are used for lower power applications. Three-phase rectifiers are used for higher power applications. Rectifiers can also be either half-wave or full-wave. Half-wave rectifiers only conduct current during one half of the AC cycle. Full-wave rectifiers conduct current during both halves of the AC cycle. Full-wave rectifiers are more efficient than half-wave rectifiers. The components of a rectifier typically include a transformer, diodes, and capacitors. The transformer is used to step up or step down the AC voltage. The diodes are used to convert the AC current to DC current. The capacitors are used to smooth out the DC voltage. The operation of a rectifier involves several steps. Firstly, the AC voltage is applied to the transformer. Secondly, the transformer steps up or steps down the AC voltage. Thirdly, the AC voltage is applied to the diodes. Fourthly, the diodes convert the AC current to DC current. And fifthly, the capacitors smooth out the DC voltage. Rectifiers are essential components in many electrical systems. They are used to convert AC power to DC power, which is required by many electronic devices. The choice of rectifier type and components depends on the specific application. Regular maintenance and inspections are essential for ensuring the reliable operation of rectifiers. Regarding magnetic field measurements, understanding the units of measurement and safety limits is crucial. The strength of a magnetic field is typically measured in Gauss, abbreviated as G, or Tesla, abbreviated as T. 1 Tesla is equal to 10,000 Gauss. The Earth's magnetic field, for reference, is about 0.5 Gauss. The International Commission on Non-Ionizing Radiation Protection, also known as ICNIRP, sets limits for exposure to electromagnetic fields. These limits are based on scientific evidence and are designed to protect the public from adverse health effects. The ICNIRP guidelines specify different limits for different frequencies of electromagnetic fields. The limits for magnetic fields are typically lower than the limits for electric fields. When taking magnetic field measurements, it is important to use a calibrated meter and to follow the manufacturer's instructions. The meter should be held at a consistent distance from the source of the magnetic field. Multiple measurements should be taken at different locations to get a representative picture of the magnetic field levels. The measurement should be compared to the ICNIRP safety limits to determine if any mitigation measures are necessary. If the measurements exceed the safety limits, steps should be taken to reduce the exposure. These steps may include shielding the source of the magnetic field, increasing the distance between the source and the people, or limiting the time that people spend in the area. Shielding can be accomplished by using materials that block magnetic fields, such as mu metal or other ferromagnetic materials. The effectiveness of shielding depends on the frequency of the magnetic field and the thickness of the shielding material. Increasing the distance between the source of the magnetic field and the people is another effective way to reduce exposure. The strength of a magnetic field decreases rapidly with distance. Limiting the time that people spend in the area is also an option, especially if the exposure is only occasional or temporary. It is important to consult with a qualified expert to determine the best course of action for mitigating magnetic field exposure. Finally, let's consider the NEC, which is a comprehensive set of standards for electrical installations. It covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. The NEC is updated every 3 years to reflect changes in technology and safety practices. The NEC is not law, but it is widely adopted by state and local governments. Compliance with the NEC is essential for ensuring the safety of electrical installations. The NEC contains many tables and articles that are relevant to the topics discussed above. For example, NEC Table 310.15, formerly 310.16, provides ampacity ratings for conductors. Ampacity is the maximum amount of current that a conductor can carry safely without overheating. NEC Article 250 covers grounding and bonding. Grounding is the process of connecting electrical equipment to the earth to provide a path for fault current to flow. Bonding is the process of connecting different metal parts of an electrical system together to create a low impedance path for fault current to flow. NEC Article 300 covers wiring methods. Wiring methods are the ways in which electrical conductors are installed. Common wiring methods include conduit, cable, and surface raceway. NEC Article 400 covers flexible cords and cables. Flexible cords and cables are used to connect portable equipment to electrical outlets. NEC Article 430 covers motors and motor circuits. Motors are used to power a wide variety of equipment, including pumps, fans, and compressors. NEC Article 440 covers air conditioning and refrigeration equipment. Air conditioning and refrigeration equipment are used to cool and dehumidify air. NEC Article 500 covers hazardous locations. Hazardous locations are areas where there is a risk of fire or explosion due to the presence of flammable gases, vapors, or dusts. These are just a few examples of the many topics covered by the NEC. It is essential for anyone working with electrical equipment to be familiar with the NEC. This ensures compliance and safety and minimizes potential hazards.